This is another dilution problem. This is, again, typically what I do when I have to make less concentrated hydrochloric acid. We have a bottle of 12 molar hydrochloric acid, which is really concentrated, and I have to dilute that. So the question is, if I want to make 250 mils of 1 molar HCl, how much of that strong acid do I need? So once again, we can use our dilution equation. M1V1 equals M2 times V2. And if we call M1, if this is our concentrated solution, we know the concentration, we just don't know the volume that we need. On the other hand, we know the volume that we're trying to make, and we know the concentration we're trying to make, so we're solving for V1. So algebraically then, V1 is going to equal M2 times V2 over M1. So simply V1 is going to equal, in this case, 1 molar times 250 milliliters divided by 12 molar. So 250 divided by 12, I'm going to need 20.83 milliliters of my 12 molar acid. And so that is going to be what I'll need to make this work. Now, the way I'm going to prepare this is I'm going to get a volumetric flask that goes up to 250 milliliters. And what I'm going to do is safety, I'm going to pour in some water first, because we always want to add acid to water. We don't really want to add water to acid. So I'm going to start off filling this up a decent amount of the way, because I know I only need 20 mils of acid, and this goes to 250, so I can fill it a decent amount. And then I'm going to pour in my 20.83 milliliters of this acid. Now that might be hard to measure. I might want to try to pick better volume to create here. But I'll add the acid in now, and then I'll fill up to the line with water. And what I'll end up having is there'll be the same volume, same moles of acid that was in the concentrated solution, but now it's dispersed over a larger volume, so the concentration drops. But the reason this whole equation works is because the number of moles of acid does not change when you dilute it. So you have the same amount of moles of acid. M times V is equal to moles of acid in each case. But anyway, that's neither here nor there. Final answer, 20.83 milliliters.